Have you ever wondered how solar cells are made? How does sunshine become electricity? The process is more fascinating than you might think. So, sit back, relax, and listen as we delve into the world of photovoltaic science and the intricate process of solar cell production. Picture this. The journey begins with silicon dioxide, which is placed into an electric arc furnace. A carbon arc is then applied to strip away the oxygen. The outcome? A blend of carbon dioxide and molten silicon. This silicon is not yet pure enough for solar cell production, though. It has a mere 1% impurity, so it must be purified further. This is where the float zone technique comes in. A rod of impure silicon is passed through a heated zone multiple times in the same direction, dragging the impurities to one end until the silicon is completely purified. Next, we move on to the creation of single crystal silicon. For this, the Czochralski method is employed. This involves dipping a silicon seed crystal into melted polycrystalline silicon. As the seed crystal is withdrawn and rotated, all impurities are eliminated, forming a pure cylindrical ingot, also known as the boule. From here, the boule is sliced into circular silicon wafers using a circular saw. These wafers are then cut into rectangular or hexagonal shapes to maximize the space on the solar cell's surface. The wafers are then polished to perfection, preparing them for the next phase. The fourth stage of the process is called doping. During this phase, impurities are intentionally introduced into the intrinsic semiconductor. This modulates its optical, electrical, and structural properties. Then comes the placement of electrical contacts. These are crucial as they connect the solar cells to the receiver of the produced current. The contacts must be extremely thin for the cell to harness sunlight effectively. Thin strips of tin-coated copper are then placed between cells. Once the contacts are in place, an anti-reflective coating is applied to the silicon wafer. This coating, usually made of titanium dioxide or silicon oxide, minimizes the amount of sunlight lost when it's reflected by pure silicon. Finally, we reach the last stage, encapsulation. The finished solar cells are sealed into ethylene vinyl acetate or silicon rubber, then placed into an aluminum frame with a Tedlar or Mylar backsheet and a plastic or glass cover. And there you have it, the intricate and fascinating process of solar cell production. From silicon purification to encapsulation, each stage is crucial to creating the solar cells that harness the power of the sun, transforming sunlight into electricity. It's a remarkable journey, one that illuminates the sophistication and complexity of this renewable energy technology.